the cosmic visitor continues its enigmatic journey. Today, October 27th, 2025, the astronomical community grapples with profound implications. Major observatories declared 3I Atlas a true black swan anomaly. Its trajectory defies known cometary motion rules. As 3I Atlas nears solar perihelion at 1.4 astronomical units, its jets flare toward the Sun, not away. This inverted outgassing challenges fundamental physics. Spectral data remains under partial embargo by ESA. This restriction fuels widespread suspicion. A significant data gap persists regarding its precise composition. Unseen forces at play. Harvard's Avi Loeb again raises the possibility of non-natural control. Fringe theorists link it to hyperdimensional propulsion or Mars-seeding phenomena. These radical ideas highlight the object's extreme strangeness. The scientific mainstream maintains cautious, neutral skepticism. They seek conventional explanations despite mounting anomalies. The data continues to challenge every existing assumption. The strangest cosmic traveler. Whatever its true nature, 3I Atlas stands as humanity's most perplexing discovery. Its true origin remains an open and pressing question. What further secrets will it soon reveal? Part 1. Discovery and Classification. A visitor beyond prediction. The initial detection hinted at an unprecedented journey. Today, October 27th, 2025, its path remains clear. This object now holds the designation 3I Atlas. An interstellar visitor, the Atlas Survey telescopes first registered a faint, moving point of light. This occurred without immediate alarm, a routine observation among countless others. Automated systems flagged a potential new comet, a common occurrence in our solar system. Initial data suggested a typical, though distant, inbound celestial body. Astronomers began to track the object with increasing precision. More observations accumulated from various global observatories. Each new data point refined the preliminary orbital calculations. The initial models still placed it within expected parameters for a long-period comet. Subsequent weeks brought a subtle shift in the projected path. The orbital eccentricity values began to trend higher than anticipated. This deviation, at first marginal, warranted closer scrutiny. The team focused on gathering more precise astrometric measurements. The object continued its approach, gaining speed. Its velocity vector became a subject of intense discussion. Early calculations hinted at an unusual, perhaps unbound, trajectory. This suggested a course that would not return to the inner solar system. By late September 2025, the evidence solidified. The object's velocity significantly exceeded the escape velocity of our Sun. This confirmed a trajectory that was undeniably hyperbolic. It would pass through our system once and then depart forever. This hyperbolic path immediately elevated its status. Such an orbit signifies a celestial body originating from beyond our Sun's gravitational influence. The implications were profound, shifting its categorization entirely. It was not merely a comet, but something far more rare. The astronomical community quickly labeled the phenomenon a black swan. This term describes an event considered statistically impossible. It behaves outside all predictive models, defying established probabilities. The object's very existence challenged current understanding. No known mechanism could account for its specific characteristics. Its approach vector and extreme velocity were unprecedented. The object moved at nearly 62 kilometers per second. This speed confirmed its non-returning path through our solar system. Scientists grappled with the implications of this velocity. It was far too high for any object gravitationally bound to our Sun. The sheer energy of its movement indicated an origin elsewhere. This was a clear signature of an extrasolar visitor. The designation process then began to reflect its unique nature. Standard nomenclature for comets no longer applied. A new class was required for objects of definite interstellar provenance. This decision marked a significant moment in astronomical classification. Unseen forces guide its passage. The formal confirmation of its interstellar origin arrived in October 2025. This pivotal announcement solidified its status. The object officially transitioned from a standard comet category. It now belonged to the interstellar class, designated 3I. This classification placed it alongside two other known interstellar objects. However, 3I Atlas presented a distinct set of characteristics. Its observed properties suggested a different formation history. It offered new data points for understanding extrasolar bodies. The shift in classification underscored its unique journey. It represented a direct sample from another star system. This provided an opportunity for unprecedented study. Astronomers now focused on its composition and physical properties. The object's behavior continued to challenge expectations. Its light curve and spectral data revealed subtle anomalies. These details further complicated its precise sub-classification. Researchers debated whether it was a comet, an asteroid, or something else entirely. The Black Swan label persisted, reflecting its defiance of models. Every new observation added to the stack of unexplained data. Its journey through the solar system offered a fleeting chance. Scientists raced to gather as much information as possible. The velocity near 62 kilometers per second remained constant. This unwavering speed confirmed its permanent departure. It would not orbit our sun, nor would it ever return. Its passage was a singular, unrepeatable event. Its journey continues. The approach vector indicated a trajectory from the direction of the constellation Lyra. This specific direction offered clues about its potential origin. However, pinpointing its exact home star system proved challenging. The vast distances involved made such an identification difficult. The implications of such an object are profound. It represents a tangible link to other stellar environments. Its presence here provides direct evidence of material exchange between star systems. This changes our understanding of galactic processes. The confirmation of its extrasolar status opened new avenues of research. Scientists began to re-evaluate existing models of planetary formation. The existence of such a fast-moving, unbound object required explanation. It forced a reassessment of current theories. The object's characteristics were meticulously documented. Its size, rotation, and any signs of outgassing were carefully recorded. Each piece of data contributed to a larger, evolving picture. This information would inform future searches for similar objects. The 3I designation signifies its third, confirmed interstellar visitor status. Each such discovery refines our understanding of the galaxy. These objects act as cosmic messengers, carrying information from distant realms. Their study is critical for broader astrophysical insights. The scientific community responded with a mixture of awe and urgency. The opportunity to observe such a visitor was fleeting. Telescopes worldwide pivoted to track its passage. Every available instrument focused on this singular event. The data streamed in, painting a complex portrait. The object's composition might offer clues about its parent star system. Its surface features could reveal the conditions it endured. This was a rare chance to glimpse another cosmic neighborhood. Its non-returning path emphasized the transient nature of this encounter. There would be no second chance for observation. This fact imbued every measurement with heightened importance. The clock was ticking on its brief visit. The initial Atlas survey detection, a routine observation, became historic. It initiated a chain of discovery that redefined expectations. The journey from a faint pixel to an interstellar designation was swift. This marked a new chapter in astronomical exploration. The Black Swan designation continues to resonate. It reminds us of the universe's capacity for surprise. Statistical models, while robust, do not encompass all possibilities. The cosmos holds phenomena beyond our current predictive grasp. The object's hyperbolic trajectory remains a key identifier. It is the definitive proof of its extrasolar journey. This unbound orbit ensures its departure from our solar system. It will continue its solitary voyage through the vastness of space. What else approaches? Part 2. Strange spectroscopic data and ESA's embargo. The initial observations offered few clear answers. Today, October 27th, 2025, new data complicate the narrative. The European Space Agency maintains an unprecedented embargo on crucial spectroscopic findings. The agency's restriction centers on information gathered by the Advanced Space Observatory. This mission, a successor to Herschel, deployed sophisticated instruments. Its NIRSpec module captured detailed readings from 3I Atlas. These unreleased findings create significant scientific tension globally. Scientists eagerly await the full compositional analysis. The European Space Agency's rationale for this data hold remains unclear. This lack of transparency raises many questions within the research community. The mission's advanced spectrometer gathers highly detailed spectral information. Such critical data typically undergoes rapid public release protocols. The current delay deviates sharply from established scientific norms. International collaborations usually ensure open data sharing. This specific situation appears to challenge those foundational principles. The scientific community expresses growing frustration with the situation. Researchers worldwide require access to these fundamental observations. Understanding 3I Atlas's elemental composition is paramount for planetary science. The embargo directly impedes comprehensive and timely analysis. This restriction affects multiple leading research institutions. The broader public remains largely unaware of this scientific blockage. Official statements from the agency offer little substantive explanation. The mission's primary goal involves stellar and planetary formation studies. Unexpected cometary readings might explain the unusual secrecy. The embargo strongly suggests a profound discovery or anomaly. Such secrecy often precedes major shifts in scientific understanding. The implications extend far beyond mere data dissemination. The scientific process depends on open scrutiny and peer review. This current situation undermines that fundamental principle. The embargo creates an information vacuum for all observers. Speculation naturally fills this void, fostering conjecture. The European Space Agency faces increasing pressure for disclosure. Their continued silence only fuels further widespread speculation. The nature of the compositional readings must be extraordinary. Otherwise, the embargo lacks logical and scientific justification. The scientific world waits for a definitive statement. This ongoing lack of clarity hampers critical research efforts. The delay affects numerous ongoing theoretical models. These models attempt to predict 3I Atlas's behavior. The embargo prevents essential empirical validation. The agency's decision impacts future mission planning. It casts a shadow over international space cooperation. The scientific community values transparent communication highly. This situation tests the limits of that trust. The reasons for the hold remain elusive. The unreleased findings continue to generate intense debate. Researchers discuss the potential implications privately. Public forums also reflect growing unease. The agency's position appears increasingly untenable. The scientific demand for answers grows louder. The advanced spectrometer gathered its data weeks ago. The processing of such information is usually swift. The delay suggests an internal struggle or profound uncertainty. The scientific implications are clearly significant. The world awaits the truth. Leaked spectral ratios provide a partial and troubling picture. These unofficial readings indicate an excess of carbon dioxide. Traces of metallic hydrogen also appear distinctly in the data. This unique composition challenges conventional cometary models directly. Solar-borne comets exhibit distinct chemical signatures. Their volatile content typically includes significant water ice. Carbon dioxide exists in these objects, but not in such pronounced excess. Metallic hydrogen remains an exotic and rare material. It forms under extreme pressures, like in gas giant cores. Finding it in a cometary object is highly unusual and perplexing. This specific spectral signature raises many new questions. No known solar system comet shares this exact profile. The leaked information suggests a non-standard origin for 3I Atlas. This finding directly contradicts established cometary science. The implications are far-reaching for astrophysics and planetary geology. The data points towards either manufacturing or extreme age. Hyper-aged interstellar chemistry offers one possible explanation. Such chemistry would involve unique evolutionary paths over eons. Manufacturing, conversely, implies an artificial construct. Both possibilities are scientifically profound and deeply unsettling. The carbon dioxide excess alone is highly significant. Its presence in such quantities defies all current expectations. The metallic hydrogen traces are even more perplexing to scientists. This material requires immense energy to form or sustain. Comets generally lack the internal conditions for its creation. The data challenges our understanding of cometary formation. It forces a fundamental re-evaluation of interstellar objects. The spectral ratios hint at a truly alien composition. This makes the European Space Agency embargo more understandable. The potential implications could be profoundly unsettling. The scientific community grapples with these unauthorized leaks. They represent a paradigm shift in cosmic understanding. The data suggests something beyond natural solar system processes, or it reveals a previously unknown natural process entirely. The distinction between these two possibilities is critically important. The source of the leak remains officially unidentified. Its impact on the scientific discourse is undeniable and immediate. The data demands careful, open, and thorough scrutiny. The embargo prevents this essential scientific process from occurring. The object's true nature remains obscured by secrecy. The spectroscopic evidence is compelling and highly persuasive. It points to an extraordinary celestial body. The implications for astrobiology and engineering are immense. This object defies simple astronomical classification. Its chemical fingerprint is unique among observed comets. The data creates a profound and enduring mystery. The scientific community requires more complete information. The embargo only intensifies the ongoing speculation. The leaked ratios suggest a non-natural origin for 3I Atlas, or an origin from extreme, unobserved conditions. The debate over its fundamental nature escalates daily. The data forces new theoretical models into consideration. Old assumptions about comets are severely challenged by these findings. The object's composition is truly anomalous. It represents a significant scientific puzzle for researchers. The embargo complicates its ultimate resolution significantly. The metallic hydrogen is particularly baffling to experts. Its presence suggests immense internal pressures within the object, or it indicates a highly advanced manufacturing process. The carbon dioxide excess adds further to the enigma. This specific combination of elements is entirely unprecedented. The data pushes the boundaries of current scientific understanding. It demands a thorough, unbiased, and transparent investigation. The embargo prevents such an essential inquiry. The scientific world awaits clarity on these findings. The unusual composition suggests deep and fundamental questions. The object's origins are deeply mysterious and complex. The agency's silence hinders progress. Unseen data whispers secrets. NASA provides additional context to this unfolding situation. A recent note highlights 3I Atlas's current trajectory. Its perihelion occurred at 1.38 astronomical units. This closest approach happened near October 29. An observational blackout coincides precisely with this period. The blackout extends through October 30th, 2025. This specific timing raises further concerns among researchers. The blackout prevents independent verification of any data. It limits direct observation during a critical orbital phase. The object is closest to the Sun during this exact time. Maximum outgassing and activity would typically occur then. The blackout obscures these potentially crucial events. This adds another layer of complexity to the mystery. The lack of observational data is profoundly problematic. It prevents confirming or refuting the leaked spectral information. The coincidence of the embargo and blackout is striking. It fuels theories of deliberate information concealment. NASA's note confirms the observational challenge faced. The blackout period is now actively underway. The object remains hidden from direct telescopic view. Its behavior during perihelion remains completely unknown. This prevents crucial data collection during a peak activity window. The timing seems almost too convenient for some observers. The lack of transparency continues to grow. The scientific community faces significant investigative hurdles. The blackout adds to the general uncertainty surrounding 3I Atlas. Direct observation is currently impossible for all instruments. This impacts all ground-based telescopes globally. Space-based assets are also significantly affected by this proximity. The object's close proximity to the Sun causes the blackout. This natural phenomenon is now amplified by circumstance. It occurs simultaneously with the data embargo. The confluence of these events is noteworthy and suspicious. It creates a perfect storm of limited available information. The scientific world waits anxiously for the blackout to lift. New observations will then become possible again. The hope is for clarity and answers after this period. The current situation remains opaque and frustrating. The connection between these events is widely debated. Some see a natural and unfortunate coincidence. Others suggest a more deliberate and orchestrated pattern. The blackout period represents a critical observational window. Its timing is highly unfortunate for scientific progress. It prevents vital data acquisition from 3I Atlas. The object's true nature remains profoundly elusive. The scientific community requires immediate answers. The blackout only deepens the ongoing mystery. It prevents confirming the object's dynamic behavior. The perihelion passage is now completely obscured. The lack of data is a major scientific setback. The situation continues to evolve rapidly. The blackout makes the object unobservable. This period is crucial for cometary study. The timing of the blackout is significant. It directly impacts our understanding. The lack of data is profoundly frustrating. The scientific community faces an impasse. The object remains hidden from view. The silence is deafening. Will the veil lift? Part 3. The jet toward the Sun. A reversal no one predicted. The previous observations of 3I Atlas had always hinted at an unpredictable nature. Today, October 27, 2025, new data emerged from deep space tracking stations. Images revealed unprecedented activity emanating from the enigmatic interstellar object. These new visual records depict massive ejections of material. These distinct plumes are not directed away from the Sun as expected. Instead, they fire vigorously towards the star itself. This orientation fundamentally challenges established physical models. Conventional cometary behavior dictates that heating from a star causes volatiles to vaporize. This process, known as outgassing, generates thrust that pushes the object away. The observed emissions from 3I Atlas defy this fundamental principle. They appear to propel the object into the very source of its thermal energy. The implications of these images are profound and immediate. Scientists across the globe are grappling with the visual evidence. The established understanding of object interaction with stellar radiation seems insufficient. A new paradigm may be necessary to comprehend this phenomenon. The ejections are not subtle or faint. They represent significant expulsions of matter. Their intensity suggests a powerful underlying mechanism. This mechanism operates in direct opposition to known thermal dynamics. Analysis of the images confirms the directionality with high confidence. The material streams are clearly visible. They extend from the object's surface towards the Sun's blinding disk. This configuration presents a critical puzzle for astrophysics. The established principles of phase transition dictate outward propulsion. Solar heating should cause surface materials to sublimate. The resulting gas and dust would create a tail pointing away from the Sun. 3I Atlas exhibits the exact opposite. This reversal of expected behavior has ignited intense theoretical debate. Early speculations struggled to reconcile the observations. No natural cometary process could explain such an orientation. The object behaves in an entirely novel manner. The initial reports caused a ripple of disbelief among researchers. Peer review of the imaging data quickly confirmed its authenticity. The visual evidence was undeniable. 3I Atlas was actively moving against the solar wind. A Harvard astrophysicist, Avi Loeb, quickly offered a provocative suggestion. He proposed that the ejections might indicate active thrust. This would imply a controlled propulsion system. Such a system would contradict any known natural formation. His hypothesis posits a deliberate, non-natural origin for the object. This idea moves beyond the realm of passive celestial mechanics. It introduces the possibility of engineered capabilities. The scientific community initially reacted with caution. The concept of field-based propulsion also entered the discussion. This alternative mechanism could manipulate local space-time. It might generate a propulsive force without conventional chemical rockets. Such technology remains theoretical for humanity. This theoretical framework suggested a controlled manipulation of energy. It could explain the violation of sublimation principles. The ejections would then be a byproduct of this advanced system. The object's behavior appears volitional. The Sun's intense glare makes current, ground-based observation extremely difficult. The powerful luminosity overwhelms sensitive instruments. Direct viewing of the object's surface activity is nearly impossible. Earth-bound telescopes struggle with the proximity to the star. The solar radiation creates a constant observational challenge. It obscures fine details of the object's structure. High-resolution imaging becomes complicated near the stellar disk. The precise nature of the ejections remains partially veiled. A temporary blackout period further complicates data acquisition. This interruption in communication stems from solar interference. Radio signals are scattered and absorbed by the Sun's plasma. Data transmission from distant probes becomes unreliable. The observational void adds to the urgency of the situation. researchers are eager for continuous, clear data streams. Every moment of lost information fuels uncertainty. The object's actions demand constant monitoring, the rules rewritten. This confluence of events has shifted all eyes to spaceborne sensors. These orbital instruments offer an unobstructed view of the solar system. They operate beyond the distorting effects of Earth's atmosphere. Their data becomes paramount for understanding 3I Atlas. Space-based telescopes possess superior resolution and sensitivity. They can penetrate the solar glare more effectively. Their vantage point is crucial for observing objects close to the Sun. They provide the clearest window into this anomaly. The reliance on these remote probes has never been greater. Their continuous data streams are essential for tracking the object. Every new image and spectral reading is scrutinized. The world waits for their next transmission. The initial images from these orbital observatories confirmed the unusual activity. Further analysis continues around the clock. Teams of scientists are dedicated to processing the incoming data. The global scientific effort is unprecedented. The implications of active thrust or field-based propulsion are staggering. Such a discovery would redefine humanity's place in the universe. It would suggest intelligence far beyond our current understanding. The universe might hold more than natural phenomena. The possibility of a non-natural origin for 3I Atlas gains significant traction. The evidence for deliberate action grows stronger. This challenges long-held assumptions about interstellar visitors. The object's behavior suggests purpose. The scientific community maintains a neutral skepticism. Yet, the data forces a re-evaluation of all prior assumptions. The observed ejections are simply too anomalous. They demand an explanation beyond standard physics. The focus now shifts from trajectory prediction to propulsion analysis. Understanding how times 3I Atlas moves becomes paramount. The direction of its material ejections offers a critical clue. This clue points towards a deeper mystery. The questions surrounding 3I Atlas have intensified dramatically. Its very nature is now under intense scrutiny. The object's behavior forces a re-examination of cosmic possibilities. What propels this object? Part 4. Avi Loeb's probe hypothesis. Re-examined, the prior enigma of interstellar visitors persists. This autumn of 2025 brings new scrutiny. A recent paper re-evaluates anomalous object behaviors. Professor Avi Loeb from Harvard University published new research earlier this year. His 2025 paper revisits his earlier arguments concerning Oumuamua. This new work focuses intently on the interstellar object 3I Atlas. He claims 3I Atlas displays peculiar characteristics near its closest approach to the Sun. Loeb's analysis suggests 3I Atlas exhibits an acceleration pattern distinct from typical comets. This pattern is described as remarkably consistent. It lacks the erratic variations often seen in natural objects. The object's increase in speed appears unusually uniform. This uniformity challenges conventional understanding of cometary dynamics. Standard models predict more chaotic behavior. Ice sublimation and gas expulsion usually create uneven forces. 3I Atlas's observed trajectory deviates from these expectations. The paper highlights the object's path close to the Sun. Near perihelion, 3I Atlas showed a precise adjustment. This maneuver implies a directed change in its course. Such a change is not easily explained by gravitational forces alone. Scientists typically attribute non-gravitational accelerations to outgassing. This process involves volatile materials sublimating from a comet's surface. The escaping gas creates a propulsive force. This jetting pushes the object slightly off its expected path. However, Loeb argues that 3I Atlas's motion is too smooth for outgassing. He suggests the observed thrust is not only constant, but also precisely aimed. This precision hints at a deliberate action. Random venting would likely produce a more irregular flight. The data indicates a continuous, gentle push. This force propelled 3I Atlas away from the Sun. The direction of this force remained remarkably stable. Such stability is difficult to reconcile with a tumbling, irregularly shaped comet. Mainstream counterarguments often cite asymmetrical venting. This occurs when gases escape unevenly from a rotating comet. One side might experience more sublimation than another. This imbalance can lead to a net force. Yet, Loeb's paper details why asymmetrical venting falls short. The observed vectoring of 3I Atlas appears too controlled. It suggests a deliberate guiding rather than a haphazard push. The object's path adjustments seem finely tuned. The trajectory of 3I Atlas near the Sun presents a puzzle. It does not perfectly align with known cometary physics. The object's behavior seems to defy simple categorization. This fuels the ongoing debate about its true nature. Loeb's research draws parallels to Oumuamua. That first interstellar visitor also displayed unusual non-gravitational acceleration. Oumuamua's lack of a cometary tail puzzled astronomers. Its flat, elongated shape was also highly unusual. The re-examination of Oumuamua's data informs this new 3I Atlas study. Loeb applies similar analytical methods. He seeks patterns that distinguish these objects from typical space rocks. Both objects present anomalous motion. The scientific community remains largely skeptical of non-natural explanations. The burden of proof for such claims is exceptionally high. Observational data must unequivocally rule out all natural phenomena. This has not yet occurred for 3I Atlas. ESA officials consistently reiterate their position. They find no definitive evidence supporting an artificial origin for interstellar objects. Their analyses focus on established astrophysical processes. The search for natural explanations continues. NASA statements maintain a similar stance. The agency emphasizes a commitment to data-driven conclusions. They stress that all observed phenomena must first be explored through conventional physics. Extraordinary claims require extraordinary proof. The debate centers on the interpretation of subtle data points. Small deviations from predicted paths can have multiple causes. Distinguishing between a natural anomaly and an artificial signature is immensely challenging. The stakes are profound. The object's precise path adjustments are particularly compelling for Loeb. He posits that these are not random deflections. Instead, they represent a form of active navigation. A probe might adjust its course for specific objectives. Such navigation would require an internal power source. It would also need a guidance system. These are features not found in typical comets or asteroids. The idea stretches the boundaries of current astronomical thought. The paper meticulously details the observed accelerations. It quantifies the deviations from purely gravitational trajectories. The consistency of these deviations forms the core of Loeb's argument. He calls for deeper investigation. The smoothness of the acceleration profile is key. It lacks the sudden changes expected from cometary outbursts. Outgassing typically produces impulsive forces. These forces vary with the object's rotation and surface composition. 3I Atlas's acceleration appears more like a steady, controlled thrust. This suggests a continuous application of force. Such an effect is hard to explain with ice sublimation alone. The physics seems to demand a different mechanism. The vectoring near perihelion also captures attention. As 3I Atlas swung around the Sun, its path subtly shifted. This shift was not merely a reaction to solar radiation pressure. It implied an active steering. If the object were a natural comet, its outgassing jets would be chaotic. They would likely point in varying directions. This would result in a less predictable, more jiggling motion. 3I Atlas appears to move with purpose. The mainstream perspective points to the unknown nature of interstellar comets. Perhaps their composition differs significantly from solar system objects. New materials could lead to novel outgassing behaviors. Our understanding may be incomplete. Some scientists propose that 3I Atlas possesses an unusual shape. An extremely elongated or flattened form could interact differently with solar radiation. This might produce unexpected non-gravitational forces. Such shapes are not unprecedented. However, Loeb's paper systematically addresses these alternatives. He argues that even exotic shapes cannot fully explain the precise vectoring. The level of control implied by the trajectory remains a sticking point. The object's stability during its closest approach is also noted. Comets often fragment or display significant activity near the Sun. 3I Atlas remained remarkably intact. Its activity level seemed subdued for its observed acceleration. The lack of a visible cometary tail also complicates matters. While not definitive, a bright tail is a hallmark of active outgassing. 3I Atlas presented minimal signs of such activity. This strengthens the argument against a cometary nature, a silent, directed journey. The paper suggests a technological origin for 3I Atlas. It proposes the object could be a piece of advanced equipment. Perhaps it is a derelict probe from an extraterrestrial civilization. This is the core of the probe hypothesis. This hypothesis challenges the fundamental assumption of natural origins. It forces astronomers to consider possibilities beyond conventional astrophysics. The implications for humanity would be immense. ESA continues to monitor interstellar objects. Their instruments are designed to detect natural phenomena. They require irrefutable proof of artificiality. Such proof has not yet materialized from their observations of 3I Atlas. NASA teams also scrutinize the data. They seek any definitive signature of technology. The agency emphasizes that current evidence points to natural processes. The scientific consensus remains firmly on that side. But tension in the scientific community is palpable. On one side, the desire to explain phenomena with known physics. On the other, the growing number of anomalies. These objects defy easy classification. Loeb's 2025 paper adds fuel to this fire. It provides new specific data points for 3I Atlas. These points strengthen his long-held view. They suggest a non-natural explanation is warranted. He argues that dismissing such possibilities stifles scientific progress. The search for life beyond Earth should extend to technological artifacts. Ignoring anomalous data might mean missing crucial discoveries. The scientific method demands rigorous testing of all hypotheses. This includes even the most unconventional ones. The data must lead the interpretation. Preconceived notions should not dictate conclusions. The question of what constitutes proof is central. How much deviation from the norm is acceptable? When does an anomaly become an indicator of something new? These are difficult thresholds to define. The observed trajectory of 3I Atlas remains the primary evidence. Its consistent acceleration and directed path adjustments are key. These behaviors are the foundation of Loeb's renewed arguments. He suggests that if a natural explanation exists, it is currently unknown. This places 3I Atlas in a category of objects that challenge our models. It requires new physics or an entirely new paradigm. The scientific community awaits further observational data. more powerful telescopes could provide clearer images. Future missions might even allow for direct sampling. These steps are years away. For now, the debate continues in scientific journals and conferences. Loeb's paper ensures 3I Atlas receives renewed attention. Its strange movements remain under intense scrutiny. The object's journey through our solar system was brief, yet its impact on scientific thought persists. The questions it raises resonate deeply within astrophysics. What if our assumptions are incomplete? The precise nature of 3I Atlas's motion is still debated. Its controlled changes near the Sun are central. These subtle shifts challenge our understanding. The scientific tension endures. What truly guides these visitors? Part 5. David Sereda and the hyperdimensional models. The precise, non-gravitational trajectory of 3I Atlas continues to defy conventional explanation. As of late October 2025, a new wave of theoretical inquiry emerges. These investigations explore the potential influence of higher spatial dimensions. Independent physicists and researchers like David Sereda now propose frameworks attempting to reconcile the observed behaviors of 3I Atlas. These parallel theories suggest that hyperdimensional geometry offers a coherent explanation for the object's anomalous characteristics. The focus shifts from conventional propulsion to the very fabric of space-time. One central enigma involves the alignment of the object's energetic jets. Traditional astrophysical models struggle to explain the observed precision and stability of these emissions. Hyperdimensional models, however, posit that these jets are not merely exhaust, but manifestations of a deeper geometric interaction. They could represent energy flows along specific axes within a higher dimensional manifold. The concept of hyperdimensional geometry involves the existence of spatial dimensions beyond our familiar three. Objects within these higher dimensions would project complex shadows or effects into our three-dimensional reality. 3I Atlas, in this view, might be interacting with or moving through these additional dimensions. This interaction could generate the observed phenomena. David Sereda's work, alongside other independent researchers, delves into the mathematical underpinnings of such a reality. Their models often incorporate concepts from string theory and other unified field theories, seeking a grander geometric order. These theories suggest that certain physical constants and phenomena are intrinsically linked to the geometry of the cosmos itself. The anomalous jet alignment becomes less mysterious when viewed through this lens. If 3I Atlas navigates higher dimensions, its movement could induce stresses or energy conduits in our three-dimensional space. These conduits would appear as highly collimated, precisely aligned jets, reflecting the underlying geometric pathways. The jets are not a result of internal combustion, but a byproduct of dimensional mechanics. Further investigation notes correlations between the spin rate of 3I Atlas and specific field harmonics. The object exhibits a rotational rhythm that appears to resonate with certain energy frequencies. This resonance suggests a non-random, possibly engineered, interaction with its environment. The spin rate might be a deliberate parameter. Field harmonics describe the resonant frequencies at which a system naturally vibrates. For 3I Atlas, these harmonics could be linked to its internal structure or its interaction with ambient space-time. A hyperdimensional object might use its spin to tune into specific energetic frequencies, drawing energy or influencing its trajectory. This tuning implies a sophisticated understanding of cosmic mechanics. The brightness intervals of 3I Atlas also present intriguing patterns. Observations reveal a golden ratio spacing in the object's luminosity fluctuations. This mathematical constant, approximately 1.618, appears repeatedly in nature and art. Its presence here suggests a fundamental design principle. golden ratio spacing in brightness intervals is not a random occurrence. It points towards an underlying intelligent design or a natural phenomenon governed by deep mathematical principles. This pattern could signify a form of communication or a highly efficient energy management system. The fluctuations are not arbitrary. Geometry dictates motion. The idea that 3I Atlas may be using geometry itself as a form of propulsion gains traction within these theoretical circles. Instead of expelling mass for thrust, the object could be manipulating the geometry of space-time around it. This manipulation would allow it to move without conventional reaction mass. It would effectively surf the fabric of existence. Such a propulsion method would explain the lack of exhaust plumes and the object's incredible maneuverability. By subtly altering the local space-time metric, 3I Atlas could create a warp field or a localized distortion. This distortion would then pull the object through space, bypassing the limitations of conventional physics. The geometry itself becomes the engine. The implications of geometry as propulsion are profound. It suggests an advanced civilization capable of harnessing fundamental forces of the universe. Their understanding of physics would far exceed our current scientific paradigms. This technology would represent a paradigm shift. The universe reveals hidden symmetries. The presence of golden ratio spacing in brightness intervals could be a signature of this geometric propulsion. The golden ratio is often associated with optimal efficiency and natural growth patterns. Its appearance here might indicate a highly optimized system for manipulating space-time. The object operates with inherent mathematical elegance. This theoretical framework provides a narrative bridge to later investigations into Fibonacci patterns. The Fibonacci sequence, closely related to the golden ratio, appears in many natural spirals and growth forms. Its potential connection to 3I Atlas's operations hints at a deeper, unified principle. The patterns are not coincidental. The ongoing analysis of 3I Atlas's rotational dynamics and energy signatures continues. Researchers scrutinize every data point for further evidence of these hyperdimensional interactions. The correlations between spin, harmonics, and luminosity provide compelling, if circumstantial, support. The data points towards a new physics. The challenge remains to develop testable hypotheses from these complex theoretical models. Experimental verification of hyperdimensional geometry is currently beyond our technological capabilities. However, the consistent anomalies observed in 3I Atlas demand new explanations. Conventional models fall short. The exploration of higher dimensions is not a new concept in theoretical physics. What is new is the application of these theories to an observed interstellar object. 3I Atlas acts as a real-world laboratory for these speculative but intriguing ideas. It pushes the boundaries of understanding. The parallel theories of David Sereda and independent physicists offer a radical departure from traditional astrophysics. They propose that the universe is far more intricate than we currently perceive. The object's behavior suggests a hidden layer of reality. The precise alignment of the jets, the resonant field harmonics, and the golden ratio brightness intervals converge. These disparate observations find a unified explanation within hyperdimensional models. The object's actions are not random. The idea of geometry as propulsion transforms our understanding of interstellar travel. It shifts the focus from brute force to elegant manipulation. This method would be quiet, efficient, and virtually undetectable by current means. It represents a silent journey. The search for definitive proof continues. Every new observation of 3I Atlas adds another piece to this cosmic puzzle. The object remains an enigma wrapped in mathematical patterns. Its secrets slowly unfold. What other patterns emerge? Part 6. The Perihelion Blackout, Missing Observations and Radio Silence. The distant, unresolved signal from the previous weeks now gives way to an unnerving quiet. Today, October 27th, 2025, marks the final hours of uninterrupted observation. Earth-based telescopes prepare for an inevitable loss of direct line of sight with 3I Atlas. This impending blackout is not unexpected, yet it amplifies existing anxieties. The object's trajectory carries it behind the sun, a celestial curtain drawing closed. For 4 critical days, from October 28th to October 31st, the sun's glare will obscure all terrestrial views. This period of silence coincides precisely with 3I Atlas's perihelion passage, its closest approach to our star. Astronomers have meticulously plotted this orbital geometry for months. They understand the mechanics of solar interference, the natural barrier it creates. Radio frequencies from Earth will struggle to penetrate the sun's plasma corona. Optical instruments will be blinded by the star's overwhelming luminosity. The blackout window is a predictable consequence of orbital mechanics. However, predictability does not equate to comfort. The scientific community has grown accustomed to continuous data streams, a constant digital tether to the interstellar visitor. Every minor fluctuation, every faint spectral signature has been scrutinized. The thought of losing this connection, even temporarily, stirs a collective unease. This period of forced observation cessation raises significant questions. What might 3I Atlas be doing during these unobserved days? Its behavior has defied simple categorization since its discovery. Each new data point has only deepened the enigma. The upcoming silence feels like a deliberate withholding of crucial information by the universe itself. The last telemetry packets arrive with a sense of finality. Observatories around the globe capture their last glimpses. These final images are processed with unprecedented speed, searching for any last-minute clues. Scientists pore over the data, knowing this might be their last concrete information for several days. The official channels maintain a composed front. Press releases reiterate the known facts of solar conjunction. They explain the technical challenges of observing an object so close to the sun. The tone is reassuring, emphasizing the temporary nature of the visibility obstruction. Yet, an undercurrent of tension persists. Behind the scenes, the atmosphere is less serene. Researchers exchange nervous emails discussing contingency plans. Some propose novel methods for data extrapolation, attempting to project 3I Atlas's trajectory with even greater precision. Others simply wait, their instruments dormant, their screens dark. The synchronized silence from ESA's real-time feed becomes particularly conspicuous. Typically, this feed provides a continuous stream of raw and processed data. It offers a window into the agency's ongoing observations and analyses. Now, its status updates grow sparse, then cease altogether. This cessation of public data raises immediate concerns. Was this an expected part of the blackout protocol? Or did it signify something more unusual? The official explanation points to the lack of new data to share. Without direct observations, the feed naturally goes quiet. Still, the sudden absence feels jarring. Community speculation begins to ripple through online forums and private channels. Whispers suggest that key telemetry may be withheld. Why would an agency stop sharing even historical data or predictive models? The absence of a constant stream fuels suspicion. Some wonder if classified information is being retained. The public has become deeply invested in the 3I Atlas phenomenon. Millions follow every development, every new image. They have grown accustomed to the transparency, the shared sense of discovery. The sudden void in information creates a vacuum, quickly filled by conjecture. This period of radio silence extends beyond the official observatories. Deep space communication networks also fall quiet regarding 3I Atlas. The signals that once hummed with data now carry only static. The entire electromagnetic spectrum surrounding the object becomes a blank canvas. The void watches. The lack of official updates prompts a surge in independent efforts. Crowd-sourced skywatch attempts proliferate. Amateur astronomers, equipped with personal telescopes and radio dishes, turn their instruments towards the sun. They hope to catch any stray signal, any faint glimmer, despite the overwhelming odds. These citizen science initiatives, though unlikely to yield definitive results, illustrate the public's hunger for information. They represent a decentralized, global effort to pierce the veil of silence. Their collective energy underscores the widespread belief that something important is being missed. For many, the blackout period feels less like a natural phenomenon and more like an imposed information embargo. The official narrative, while scientifically sound, struggles to quell these emerging doubts. The absence of data creates a fertile ground for alternative theories. Some suggest that the sun's interference might be more than a simple obstruction. Perhaps it masks a more complex interaction. The intense solar radiation could be affecting 3I Atlas in unforeseen ways. Or perhaps, conversely, 3I Atlas is somehow utilizing the solar environment. The possibility of deliberate holdback gains traction among certain groups. They argue that governments or space agencies might be concealing sensitive discoveries. If 3I Atlas were exhibiting truly anomalous behavior, they reason, such information might be deemed too destabilizing for public release. This line of thinking, though lacking concrete evidence, taps into a pervasive distrust. It suggests a hidden agenda, a secret understanding of the object's true nature. The silence, in this view, is not a void, but a carefully constructed barrier. The official stance remains steadfast. The blackout is a purely astronomical event. It is a predictable consequence of orbital mechanics and the limitations of current technology. Any suggestion of deliberate concealment is dismissed as unfounded speculation. Yet, the timing of the blackout adds to the narrative of suspicion. It occurs precisely when 3I Atlas is at its closest point to the sun. This proximity could, theoretically, offer the best opportunities for observation, were it not for the solar glare. The most critical moments are now the most opaque. Researchers at various institutions continue their work, analyzing pre-blackout data. They run simulations, refine models, and debate potential scenarios. Their discussions are characterized by a blend of scientific rigor and growing apprehension. The unknown weighs heavily on their minds. The silence is absolute. The days tick by slowly, each hour without new information stretching into an eternity. The world holds its breath, collectively waiting for October 31st to pass. The return of visibility promises to either confirm the natural explanation or reveal something far more profound. The crowd-sourced efforts, despite their limitations, continue. Amateur radio operators scan frequencies, listening for any deviation from expected solar noise. Astrophotographers attempt long exposure shots, hoping to capture a faint, improbable trace. Their dedication is unwavering. The absence of official communication regarding 3I Atlas's current status is unprecedented. Even during previous periods of reduced visibility, some form of update or projected data was usually provided. This complete cessation is a new development. This lack of transparency, whether intentional or not, exacerbates the uncertainty. It transforms a routine astronomical event into a period of acute suspense. The narrative shifts from scientific observation to a more thriller-like atmosphere. The core question persists. Is this merely the predictable consequence of solar conjunction? Or is there a layer of deliberate information control at play? The answer remains, shrouded in the sun's blinding light. The world waits for the light to fade. The scientific community finds itself in an uncomfortable position. They must uphold the principles of scientific explanation while acknowledging the public's growing unease. Explaining the mechanics of solar interference does little to calm the apprehension. The sheer scale of 3I Atlas's journey adds to the mystique. It has traveled across vast interstellar distances, only to become temporarily invisible at its closest approach. This irony is not lost on those who follow its path. The data drought forces a re-evaluation of existing theories. Without new input, scientists must rely solely on past observations. This limitation highlights the fragility of their understanding, dependent as it is on continuous input. The synchronized quiet from the European Space Agency's public feeds becomes a focal point of discussion. Its previous reliability and openness make its current quietude stand out starkly. What internal discussions led to this decision? The possibility of an intentional holdback is not openly discussed in official scientific channels. Such suggestions are quickly dismissed as conspiracy theories. Yet, the concept lingers in the periphery of public discourse. The amateur skywatch attempt, while largely ineffective against the sun's glare, serve a critical function. They provide an outlet for public engagement and a symbolic resistance to the information blackout. They keep hope alive. The lack of any confirming or denying statements regarding suppressed telemetry only deepens the mystery. The absence of information becomes a form of information itself, interpreted in various ways. The period of invisibility is a test of patience and trust. It challenges the public's faith in official narratives. It forces a confrontation with the limits of human knowledge and observation. The perihelion blackout is more than an astronomical event. It is a psychological one. It plays on fears of the unknown, of hidden truths. It transforms a celestial body into a source of profound human anxiety. The sun's intense radiation, while obscuring 3I Atlas, also prevents any direct confirmation of its state. Is it dormant? Is it active? The answers are lost in the solar static. The scientific models, once robust and predictive, now feel incomplete. They can project trajectory, but cannot account for potential behavioral changes during the unobserved period. The global network of observatories, usually a source of collective strength, is now collectively blind. Their advanced instruments are rendered temporarily useless by a fundamental astronomical phenomenon. The quiet from the agency's public feed is a stark reminder of this collective blindness. It underscores the sudden cessation of any verifiable data, leaving only room for conjecture. The very act of public skywatching, born of desperation, embodies the spirit of human curiosity. It represents an unwillingness to accept the darkness without resistance. The speculation about data suppression grows louder with each passing hour of silence. The absence of facts breeds a proliferation of theories, some more outlandish than others. The sun, usually a source of life, has become an impenetrable barrier. It hides 3I Atlas from view, transforming it into a phantom object, existing only in memory and projection. The thriller tone intensifies as the blackout continues. The stakes feel higher, the unknown more menacing. The narrative is driven by what is not seen, not heard. The official explanations, though scientifically sound, feel inadequate to address the rising tide of public suspicion. They do not account for the emotional impact of the information void. The mystery of 3I Atlas deepens with its invisibility. Its true nature, its purpose, its very state of being, become subjects of intense, unverified debate. The coordinated quiet across all major observational platforms creates an eerie uniformity. It suggests a synchronized response, whether by design or by necessity. The public's attempts to pierce the blackout, however futile, are a testament to their enduring fascination. They refuse to be passive observers in this cosmic drama. The potential reasons for the quiet, solar interference, or intentional holdback frame the entire discussion. These two possibilities represent vastly different implications. The period of missing observations feels like a pause in a grand, unfolding narrative. What will resume when the curtain lifts? What will be revealed? The scientific community braces itself for the post-blackout analysis. They prepare for a flood of new data, or perhaps for continued ambiguity. Its current actions remain unknown. The blackout is a stark reminder of humanity's limited perspective. We are confined to our planet, our instruments constrained by celestial mechanics. The speculation about data withholding suggests a deeper layer of control, a narrative being managed rather than simply observed. The amateur endeavors, while limited, represent a powerful democratic impulse in the face of scientific opacity. The sun's blinding light conceals all. The tension builds with each passing moment of silence. The world awaits the end of the blackout. What emerges next? Part 7. The Fibonacci signal rhythmic pulses in the light curve. The object's inexplicable inertness has long defined its enigmatic presence. Today, new data shifts the focus from its physical composition to its temporal patterns. Recent photometric observations reveal a series of rhythmic brightness pulses emanating from 3 Atlas. These pulses present an intricate sequence of light fluctuations. Astronomers at Gemini North have meticulously analyzed the variations. The data suggests a structured, repeating pattern within the object's light curve. This discovery marks a significant shift in understanding its observed behavior. The pulses occur at intervals that appear to align with a specific mathematical progression. Initial analysis highlights a sequence matching Fibonacci ratios. These ratios follow the pattern of 1, 1, 2, 3, 5, and 8 units. Such a precise numerical correspondence demands closer scrutiny. The October 2025 Gemini North photometry set provides the most compelling evidence. This dataset captures the light variations with unprecedented detail. It detects a harmonic pattern that repeats consistently. This repetition occurs every 233 seconds. The detection of such a precise periodicity raises immediate questions. Is this merely a natural phenomenon, or something more deliberate? The scientific community has begun to debate the implications of these findings. 2 primary hypotheses currently dominate the discourse. One hypothesis proposes that the observed pulses result from rotational modulation. This theory suggests that the object rotates, and its surface features cause the brightness changes. Irregularities on the surface or varying reflective properties could create such a pattern. This would be a natural, albeit complex, astrophysical process. However, the specific nature of the detected pattern complicates this simple explanation. A natural rotation would typically produce a more uniform, sinusoidal light curve. The appearance of Fibonacci ratios introduces an element of unexpected order. This order seems too specific for random surface variations. The second, more provocative hypothesis suggests encoded signaling. This theory posits that the rhythmic pulses are not accidental. Instead, they might represent a deliberate transmission. The Fibonacci sequence, a universal mathematical constant, could serve as a recognizable code. This idea challenges the conventional understanding of interstellar objects. It implies an intelligence capable of generating and transmitting such a signal. The implications of this theory are profound, requiring careful consideration. Scientists must explore all possibilities with an open yet rigorous approach. The debate among scientists is intense, yet grounded in empirical data. Proponents of rotational modulation cite the absence of other artificial markers. They emphasize that complex natural processes can mimic designed patterns. Stellar flares and planet transits can also create intricate light curves. However, the consistent appearance of the Fibonacci sequence remains a strong counterpoint. Such a precise mathematical signature is statistically improbable in purely random systems. The argument for coincidence weakens with each additional observation. The pattern persists across multiple Gemini North observations. Further analysis of the photometric data focuses on the exact timing of the pulses. The precision of the 233-second repeat cycle is remarkable. This exactitude suggests a mechanism with high temporal control. Natural rotational periods can vary slightly due to internal dynamics. The object's light curve shows distinct peaks and troughs. These fluctuations are not merely gradual changes in brightness. They are sharp, well-defined pulses. This characteristic further supports the idea of a structured emission. A natural rotation might produce smoother transitions. Scientists are attempting to model various rotational scenarios. They are exploring how an irregularly shaped object might produce such a pattern. Perhaps a highly elongated or tumbling object could generate complex light curves. Yet, matching the Fibonacci sequence proves difficult. The possibility of surface features arranged in a Fibonacci-like spiral is also considered. Such a configuration could, in theory, create the observed pulses. However, this would require an extremely specific and unlikely geological formation. The probability remains low for a natural occurrence. The encoded signaling hypothesis explores the sequence as a mathematical prime. The Fibonacci series is fundamental across many scientific disciplines. It appears in nature, but also serves as a common basis for information theory. Its presence could represent a deliberate choice for communication. If the pulses are indeed a signal, their purpose remains unknown. Are they a beacon, a message, or simply an operational emission? The nature of the information conveyed, if any, is beyond current decipherment. The first step involves confirming the artificiality of the pattern. The Gemini North data provides a critical new dimension to the 3-eye Atlas mystery. Previous observations focused on its trajectory and composition. Now, the focus shifts to its dynamic properties. The light curve offers a direct, observable phenomenon for study. The rhythmic pulses are not subtle. They are pronounced. Their amplitude changes are significant enough to be reliably detected. This robustness lends credence to the observations. It diminishes the likelihood of measurement error or noise. The scientific team at Gemini North continues to acquire more data. They are attempting to extend the observation period. Longer datasets will allow for more rigorous statistical analysis. This will help to confirm or refute the persistence of the Fibonacci pattern. The light curves hold secrets. The debate extends beyond the immediate scientific community. Public interest in 3-eye Atlas has always been high. This new data intensifies speculation about its origins. The question of natural versus artificial becomes more urgent. Some researchers suggest that even if natural, the Fibonacci pattern is extraordinary. It represents an exceptional astronomical coincidence. The universe can produce surprising patterns. However, such precise mathematical alignment is rare. Others argue that invoking coincidence avoids deeper investigation. They believe that extraordinary patterns demand extraordinary explanations. The complexity of the observed rhythm points away from simple randomness. It suggests an underlying principle or design. The 233-second repeat cycle is particularly intriguing. This specific duration adds another layer of specificity to the pattern. It is not an arbitrary number. It is a precise measure of time between harmonic repeats. The implications for astrophysics are profound. If rotational modulation, it would redefine complex light curve analysis. If encoded signaling, it would fundamentally alter humanity's perception of its place in the cosmos. Both possibilities are revolutionary. The current challenge lies in differentiating between these two scenarios. Scientists are developing new analytical tools. These tools aim to distinguish between highly ordered natural phenomena and deliberate artificial constructs. The task is formidable. The data from Gemini North is being cross-referenced with other observatories. Confirmation from independent sources would strengthen the findings. This collaborative effort is crucial for validating the initial observations. The scientific process demands independent verification. The possibility of deliberate synchronization cannot be easily dismissed. The choice of the Fibonacci sequence appears too specific. It resonates with mathematical principles known across diverse cultures. This universality might be intentional. The object continues its silent journey. Its light pulses speak a cryptic language. The scientific community grapples with the implications. Is this pattern a random cosmic whisper, or a deliberate message across the void? Part 8. Solar Trap and Mars Seeding Theories. The unconventional trajectory of 3I Atlas continues to defy simple explanation. Today, new theoretical models suggest an even more profound interaction with our cosmic neighborhood. Reports now detail how an interstellar object might profoundly influence planetary environments. This theoretical framework posits a solar trap mechanism. As the object traverses the inner solar system, it encounters the solar wind and the sun's magnetic fields. These powerful forces can exert significant drag on minuscule particles shed from the comet. Such particles might then become gravitationally bound within the vast expanse of the heliosphere. The solar trap could accumulate a significant diffuse cloud of material. This material would originate directly from the comet's nucleus, ejected during its perihelion passage. It could include both complex organic molecules and fine metallic dust. These components represent the pristine, unaltered composition of the interstellar visitor, a relic from another star system. Scientists propose that the comet, during its closest approach to the Sun, released these particles. The release mechanism could involve intense sublimation of volatiles or tidal stresses from solar gravity. This process would create a persistent, diffuse trail of material. This trail would then slowly disperse throughout the inner solar system, influenced by solar radiation pressure. The heliosphere acts as a natural containment zone for these particles. It effectively traps these minute fragments, preventing their escape back into interstellar space. Over time, the concentration of this interstellar dust could steadily increase. This phenomenon presents a unique and unprecedented opportunity for scientific observation of exogenic material. Further analysis suggests a distinct potential for atmospheric deposition events. Some of this trapped material could eventually spiral inward towards the Sunday. It might then interact with the upper atmospheres of the inner planets. Mars, with its relatively thin atmosphere, represents a prime candidate for such an event, offering less resistance to incoming particles. The red planet's tenuous atmosphere offers significantly less resistance than Earth's. Interstellar particles could penetrate more deeply into its atmospheric layers. They might then settle onto the Martian surface, undisturbed by strong winds. This process introduces foreign material directly into a planetary ecosystem, altering its chemical profile. This deposition could involve complex organic compounds, crucial for life. These are the fundamental building blocks of life as we understand it. The implications for astrobiology are profound and considerable. It raises fundamental questions about the potential origin of life on other worlds within our solar system. Alternatively, the deposited material could be predominantly metallic in nature. Such particles might consist of rare isotopes or unique, non-natural alloys. Their presence would strongly indicate an advanced technological origin. This possibility expands the scope of the investigation beyond purely natural phenomena. The solar winds push, the fields hold. The metallic fragments might display anomalous crystalline structures. Their elemental ratios could deviate from known cosmic abundances. Such findings would point towards artificial fabrication. This evidence would challenge our understanding of interstellar objects. Recent reports from a Mars orbiter add a compelling layer to these theories. The spacecraft detected an anomalous atmospheric event. It registered a faint luminous trail high above the Martian surface. This observation occurred precisely during the comet's closest passage through the inner solar system. The faint, luminous trail. The trail appeared entirely consistent with dust interaction at high altitudes. Atmospheric friction would cause such incoming particles to glow intensely. The light signature matched expectations for micron-sized debris. This debris would enter the atmosphere at extremely high velocity, generating heat. Orbiter instruments captured detailed spectral data from the event. Preliminary analysis indicates a complex and unusual chemical signature. This signature does not align perfectly with typical Martian dust or known meteoritic compositions. It strongly suggests an external, non-indigenous source, unlike anything previously observed. The precise timing of this observation is undeniably crucial. It directly correlates with the comet's projected trajectory and proximity to Mars. The comet passed within optimal orbital proximity of the red planet. This close proximity strongly supports a direct causal link between the object and the luminous trail. You must consider the sheer scale and persistence of such an event. If the object is indeed shedding material, the total volume could be vast. A continuous stream of fine particles might be steadily entering our solar system. This stream could potentially persist for an extended period, long after the object departs. The solar trap theory offers a plausible and comprehensive explanation. It connects the comet's unique properties to the observed atmospheric phenomena. It suggests a viable mechanism for interstellar material transfer. This transfer could have profound and long-term effects on planetary evolution. One interpretation centers heavily on the concept of panspermia. This theory proposes that life's fundamental seeds travel through the cosmos. 3I Atlas, in this context, could be a natural vector for such biological dissemination. It might be delivering organic precursors or even dormant microbes to planets. Are we witnessing panspermia in real time, unfolding before our eyes? This profound question gains new urgency with the Mars observation. The luminous trail on Mars could be direct, unequivocal evidence. It suggests a biological exchange occurring across vast star systems. The implications for Earth's biosphere are also highly significant. If Mars receives such biological deposits, Earth might too, albeit indirectly. Our planet's much more robust atmosphere would likely filter much of it. However, some resilient material could still reach the surface. This process could introduce novel biological agents or genetic material. It might also enrich existing planetary biospheres with new compounds. The concept fundamentally challenges our understanding of life's origins. It suggests a wider, interconnected cosmic web of biological transfer. Another compelling perspective considers the unknown technology hypothesis. The precise shedding mechanism of the comet remains entirely unclear. The controlled nature of the deposition could strongly suggest artifice. It raises the distinct possibility of deliberate planetary seeding or reconnaissance. Perhaps 3I Atlas is not merely a natural, inert comet. Its unique characteristics and unusual behavior have consistently puzzled scientists. The observed events might be part of a larger, orchestrated design. This design could involve highly advanced interstellar engineering. The luminous trail on Mars might therefore be a carefully executed test. It could represent a deliberate release of microscopic probes or sensors. These probes might be specifically designed for atmospheric entry and data collection. Their ultimate purpose could be planetary reconnaissance or environmental modification. Such advanced technology would operate at an almost imperceptible scale. It would be extremely difficult to detect directly with current instruments. The faint glow generated by atmospheric friction would be its only observable signature. This stealth approach aligns perfectly with highly advanced capabilities. The composition of the micromatter becomes critically important here. If it contains highly organized, non-random structures, it points to design. Complex molecular arrangements or self-replicating units would suggest manufacture. This evidence would shift the scientific paradigm entirely. The question then becomes one of profound intent. Is this a benign seeding operation, a cosmic gardener at work? Is it a preliminary survey by an unknown advanced intelligence? The answers hold profound and far-reaching consequences for humanity's future. We face two distinct, yet equally profound, possibilities for the object. Both challenge conventional scientific paradigms and established beliefs. Both demand rigorous, unbiased investigation and transparent data sharing. The data from Mars, therefore, requires immediate and further scrutiny. The next critical steps involve even more detailed spectral analysis. Researchers must meticulously compare the Martian trail's unique signature. They will compare it with known interstellar, terrestrial, and artificial materials. This exhaustive comparison will significantly refine our understanding of the event. Future missions to Mars could actively seek direct, tangible evidence. Surface samples from targeted regions might reveal interstellar deposits. The discovery of such material would be monumental. It would unequivocally confirm one of these speculative, yet compelling theories. The nature of 3I Atlas remains profoundly enigmatic. Its passage through our solar system offers an unprecedented opportunity. We observe cosmic processes of immense scale unfolding before us. The implications resonate deeply within the scientific community and beyond. The possibility of life's transfer across vast interstellar distances is compelling. It fundamentally redefines our place within the universe. The alternative, an engineered intervention, is equally transformative for our worldview. Both scenarios require careful, open-minded consideration. The accumulating data strongly suggests a deliberate interaction. The precise timing of the Mars atmospheric event is particularly striking. It aligns too perfectly with the object's trajectory and proximity. This alignment hints at more than mere celestial chance. The scientific community remains sharply divided on the interpretation. Some favor the naturalistic, albeit extraordinary, explanation of panspermia. Others lean towards the technological interpretation, considering it a form of alien activity. Both camps acknowledge the truly extraordinary nature of the observations. The search for definitive answers continues with unwavering resolve. Each new piece of data refines the complex picture further. The stakes involved are immeasurable for our civilization. Our understanding of cosmic life and intelligence hangs in the balance. What does it mean? The long vigil for an interstellar visitor culminates. Today, 27th of October, 2025, marks the critical window. 3I Atlas approaches its closest point to the Sun within mere hours. Observatories worldwide focus their instruments. Teams of astronomers hold their breath. They track every photon, every spectral shift, analyzing data in real time. This moment defines the mission. It represents the ultimate test for an object from beyond our solar system. Its peculiar journey defies prior prediction. The scientific community braces for two stark possibilities. One involves spectacular disintegration. The other suggests unprecedented survival. Either scenario rewrites textbooks. Both challenge our understanding of interstellar objects. No prior visitor presented such a profound dilemma. Oumuamua and 2I Borisov offered glimpses. They hinted at the unexpected. 3I Atlas pushes beyond mere anomaly. Its resilience, or lack thereof, speaks volumes. The solar furnace awaits its passage, millions of kilometers separated from oblivion or triumph. This event embodies the true meaning of a black swan, a rare, unpredictable occurrence. Its impact carries extreme consequences. It defies historical precedents. It forces radical re-evaluation of established theories, reshaping scientific disciplines, an unknown architect's design. If 3I Atlas endures the solar torment intact, implications are staggering. It challenges astrophysics foundations, requiring complete overhaul of interstellar matter models. The universe reveals its secrets slowly. Such an outcome forces a new question. The nature of objects able to withstand close solar encounters becomes paramount. Its inexplicable durability demands explanation. A more profound possibility then emerges. Something out there might actively craft these visitors, with intelligence guiding their journeys. This remains a speculative, enduring leap. The data, whatever it reveals, informs the next chapter, confirming our limits or expanding our cosmic horizon. The moment of truth arrives. Our collective understanding hangs in the balance. The universe prepares its verdict. Does intent guide its path?